This video demonstrates how to debug sketches using the RL78 Arduino library on a Windows PC within the Arduino IDE. Debugging allows you to collect detailed information from your sketch and observe the internal behavior of the library. Please note that this video assumes you've already created and compiled the sketch you want to debug. If you haven't completed that setup yet, please refer to the Quick Start Guide linked in the video description to get started. We will use the following software in this explanation. For more detailed information about each software, please refer to the video description. We will use the following hardware for this explanation. Detailed information about the hardware is also provided in the video description, so please refer to it. If you are using different software or hardware, some operations or settings may differ from those shown in this guide, so please proceed with caution. Next, we will explain the operation procedure in the Arduino IDE. First, create a file named debug custom.json. In the Arduino IDE editor, click the menu icon and select New tab. Enter debug custom.json and click OK. Next, copy and paste the code shown on screen into the newly created debug custom.json file. You can find this code on the Wiki page linked in the video description, so we recommend copying it from there. This code serves as a template, and you'll need to modify it to match your environment. Specifically, replace COMXX with the port number of the board you are using. To enable more detailed debugging, go to Sketch and select Optimize for debugging. Next, perform the debugging process. Connect the PC and RL78 G23-64p FPB with a USB cable. Once the sketch has been written to the board, click Start Debugging. As you can see, you can now debug directly within your sketch. Let's go over the basic debugging features. To set a breakpoint, click to the left of the line number where you want the program to pause. When a breakpoint is set, the program will stop at that line during execution. In this example, we'll set a breakpoint at the beginning of the loop function and run the program. The program stops at the start of the loop function as expected. Next, by executing step in, the program enters the function and pauses. You can check the values of local variables in the variables and the values of specific expressions in the watch. Executing step out allows the current function to run to completion and return to the calling function, where the program pauses. By using these features, you can collect more detailed information from your sketch and observe how the library behaves internally. For more detailed information about the RL78 Arduino library, please visit the Renesas Arduino website on GitHub.